Specific heat capacity. If an object is given heat energy, its temperature will rise, unless there is a change of state. Here we have a kilogram of water, a kilogram of aluminium, and a kilogram of copper. Copper has got a higher density than aluminium, hence the smaller volume to have a kilogram. And aluminium has a higher density than water, hence its smaller volume than the water. If we place identical heaters in each of the objects and have thermometers to record the temperature rise, when we give each of the blocks the same amount of heat energy, we get this happening. The same amount of energy does not produce the same temperature rise in the same mass of different materials. The specific heat capacity of a material is the heat required to produce unit temperature rise, that is 1 Kelvin or 1 degree C of temperature rise, in unit mass, or 1 kilogram, of the material, as long as there is no change in state. In formula terms, we have the energy in joules is equal to the mass in kilograms multiplied by the specific heat capacity in joules per kilogram per Kelvin multiplied by the temperature change in Kelvin, or can be in degrees Celsius. That's because a change of temperature in Kelvin is the same as the change in degrees Celsius. Energy can be given the symbol E or Q. Mass tends to always be given the symbol M. Specific heat capacity is normally given a little c, and temperature change would be delta theta or delta T. So we get Q is equal to mc delta theta, or you could have variations on the same equation. Water has a very high specific heat capacity of 4,200 joules per kilogram per Kelvin, meaning a lot of energy has to be provided for a small temperature rise. Copper, on the other hand, has a much lower specific heat capacity of just 385 joules per kilogram per Kelvin, meaning the temperature would rise by almost 11 times as many Kelvin, 4,200 divided by 385, giving 10.9, as would the same mass of water, given the same amount of energy. Let's look at an example. A 700 gram block of aluminium is given 12.6 kilojoules of energy, and its temperature rises from 20 degrees C to 40 degrees C. Calculate the specific heat capacity of aluminium. Well, we need the formula Q equals mc delta theta, and just putting down the information we have, we know that the energy Q is 12.6 kilojoules, or 12.6 times 10 to the 3 joules. The mass is given in grams, so we must multiply it by 10 to the minus 3 to get it into kilograms. And the change in temperature from 20 degrees C to 40 degrees C is a rise of 20 degrees C, or 20 Kelvin. Now all we need to do is rearrange this equation for C, which I've done here, put in the numbers, and we get a specific heat capacity of 900 joules per kilogram per Kelvin, meaning 900 joules of energy would be needed to raise 1 kilogram of aluminium by 1 Kelvin.